In the last session, we had a brief discussion about RAM, types of RAM, and also about ROM. You can quickly recall, in the first session, we had a discussion on memory hierarchy. When you talk about memory hierarchy, you can see the diagram here. We have a memory called as auxiliary memory or secondary memory. Of course, this is already known to you. They are permanent in nature. The contents of auxiliary storage or auxiliary memory or secondary memory, they are non-volatile. Of course, I did give an example of auxiliary storage or secondary memory, the magnetic disk or your USB. One more memory that comes as a part of auxiliary storage is magnetic disk. Apart from magnetic disk, one more storage is magnetic tape. So tape is another example of auxiliary storage. When you look at tape and disk, what are the essential differences? Tape is sequential in nature, or when I mean sequential, whenever you want to read the contents of a tape, it permits only sequential access. You know, you can quickly recall, in olden days, we used to make use of a tape recorder. And whenever you wanted to hear a song in a cassette, you can do fast forwarding, you can do rewinding, and so on and so forth. But you cannot directly go to that particular song or to a particular location to play the tape. You have to fast forward. That means you have to go from song number 1 to song number 5. Though you don't listen to that song, you cannot directly play the 5th song. That means direct access is not possible in the case of a tape or tape recorder. We make use of a cassette then. Nowadays, cassette and tape recorder have been outdated now. Similar to the same principle, we have got magnetic tape, which stores a record. You know pretty well what is a record. A record is a collection of fields. What is a field? A field is nothing but a collection of characters. For example, if you take up employee record, employee number, employee name, employee's designation, date of joining, date of birth, designation, then salary, etc. They are examples of fields. You can also call them as attributes. When you combine all the fields together, it forms one record. When you look at an organization, there will be number of employees. For each employee, you will maintain one record. And if there are going to be 1,000 employees, there will be 1,000 such records. And these records will constitute a file or will make up a file. If that is called as employee file. Therefore, I can put this way: a file is a collection of records. A record is a collection of fields or data items, and each and every data item is made up of or denoted by characters. And each and every data item will have value. For example, employee number. Each and every employee number will be unique. Employee name may be duplicated. There may be more than one employee with the same name, but their ID will be unique. In a similar sense, when you come to magnetic tape, it is going to store contents record by record. The beauty about tape is that it is not running at constant speed. When you start the tape, it will take some time for the tape to reach the constant speed, and then it runs at the constant speed. And then this is when you start the tape, it takes some time to reach the constant speed. Only when it is running at constant speed, it is able to perform either reading operation or writing operation. When you are going to stop after reading the record, again it takes for the tape to come down from the normal speed or constant speed. Again it has to stop. Therefore, during the start time and the stop time, the tape will take some time to go and reach a normal speed or constant speed. Once it is running at the constant speed, you perform either reading the record or writing the record. Once that is done, again you have to stop. So therefore, what happens? You can perform reading and writing in the case of a tape only when it is running at constant speed. While starting and stopping, it won't be running at the constant speed. It takes some time to gain that momentum. At that point of time, you cannot do any writing or reading. that portion of tape is wasted. That is referred as the gap. That means in between two records, there will be a gap that is called as the inter-record gap. For the first record, there will be a start gap because you're going to start the tape. It has reached a constant speed. While it has reached a constant speed, assume you are performing writing operation, write into the tape. After writing the record is done, you have to inform the tape that writing is done or over, and then you have to stop the tape. While stopping, it has to reduce its speed and come down to the halt state. Therefore, some amount of tape or memory portion will be wasted, and that gap is referred as your inter-record gap between record 1 and record 2. So that there will be a start gap and the stop gap. For the first record, you have a start gap, and then you have your first record, then followed by the stop gap. For the second record, there will be a start gap. Why? Because you have to start again making the tape to run to reach a constant speed. Some amount of tape space is wasted. That is got as the start gap for the second record. While running at constant speed, you perform the writing operation for the second record. That is for the second employee, for instance. Then you stop after writing the second record. So there will be a stop gap for the second record. That means for the first record, you have a stop gap. And for the second record, you have got a start gap. The stop gap of the first record and the start gap of the second record combined together, it is referred as the inter-record gap. That means in between two records, there will be a gap. That gap is called as the inter-record gap. In this inter-record gap, it is a portion which is wasted by the tape. Why? Because nothing could be stored over there. The reason being the tape is not running at the constant speed at this point at this interval of time or at this point of time. Either it is starting or it is stopping. Therefore, no useful data can be stored when tape is not running at the constant speed. Therefore, some amount of storage space on the tape is wasted, and that is referred as the gap. So kindly keep in mind, for each record, there will be a start gap and a stop gap. When you consider two consecutive records, the stop gap of the first record and the start gap of the second record combined together is referred as the inter-record gap. Therefore, this is the point you have to keep in mind. And storage space wasted is more. And time taken to access the record will vary in the case of a magnetic tape. Why? Because the time taken to read the first record is less, whereas I want to read the ith record, I have to traverse through the first I-1 records. Then only I'll be able to read the ith record. Therefore, the access time of reading the record from the magnetic tape is not going to be constant. It is going to vary. The access time is not constant factor. It is going to be a varying factor. It depends on the position of the record on the tape. So this is a point you have to keep in mind with respect to the tape. And tape is very slow in speed. That is the reason why earlier in your olden days, people are using magnetic tape as a backup storage device. And it is cheaper than disk. The cost of a magnetic tape is cheaper than the cost of a magnetic disk. Therefore, the magnetic tape is going to make use of a magnetic material for storing the information. And the magnetic tape is made up of tracks. Assume you are going to use an 8-bit track. Each and every character will be stored vertically. The topmost track is called as the parity track, and the bottom 7 tracks are referred as your character. You know pretty well, in the case of ASCII, American Standard Code for Information Interchange. It is a 7-bit code. To represent one character, we require 7 bits. Therefore, 7 tracks are meant for that purpose. And the topmost track, as I mentioned before, it is called as the parity track. It can be either odd parity or even parity. You would have known what is a parity bit. Either the number of bits can be even or number of bits can be odd. Depending on that, you can have either the odd parity bit or even parity bit that is decided by the manufacturer. For example, I am going to store, let me say character A. Character A is equivalent to 65. You know, you would have studied. It is equivalent to, in 65 in decimal, is equivalent to 1000001. This is a binary equivalent. Therefore, character A is represented as 100, the 3 topmost bits, and the lower four bits are 0001. If I'm going to add a parity bit, assume it is going to be even parity, count the number of ones in A, whose equivalent is decimal number 65, whose binary equivalent of 65 is 1000001. There are two ones already present. Therefore, the even parity bit must be 0. Why? Because Even parity means you are making the number of ones present in that character as even. A is a one character. Already in A, represented in binary, which is equivalent of 65, it has already two ones. Therefore, I'm going to keep the bit as what is 0. In the case of B, yeah, it is going to be 66. It is going to be 100 0010. Again, you count the number of ones. It is going to be 2. Therefore, even parity bit is going to be 0. When you come across C, it is going to be 67. It will be 100 0011. When you count the number of ones, in the case of 67, there are 3 ones. If it is going to be even parity, the topmost track I told you called as a parity bit. If it is going to be even parity storage, then you have to put that extra parity bit as 1. In the first 2 cases, for A and B, which is 65 and 66, since there are already even number of ones present in your character, the even parity bit happens to be 0. Whereas in the case of C, it is going to be 67. Since there are odd number of ones present, namely 3, to make it even, you have to add that extra bit, namely the parity bit as 1. Therefore, this is what we call them as even parity, and odd parity is mutually exclusive. What is the meaning of the odd parity? When the number of ones are odd, it will be 0. When the number of ones are even, it is going to be 1. So, you know, these two are mutually exclusive. This is how a magnetic tape stores your characters. Remember, tape is basically a sequential device. It stores data in terms of tracks. Assuming it stores ASCII characters or adopting ASCII code or ASCII coding mechanism, it is going to have 7 tracks for representing the ASCII coding characters, and then the topmost track or the one at the lying at the top is referred as your parity track. Totally 7 plus 1. In general, if you are going to use an n-bit code, there must be n plus 1 tracks. And what is the advantage of tape? It is very, very cheaper in terms of cost, but it is taking exorbitant time to perform either reading operation or writing operation. So that's the problem with respect to the tape. And of course, you do know there will be a gap between one record and another record. You call them as the inter-record gap. To minimize the wastage, instead of reading only one record or writing one record at a time, you perform writing and reading operation in bulk. That means, when I mean bulk, for example, I am going to consider a block of 4 records. Either I will read 4 records at a time or I will write 4 records at a time, which means that in between 2 blocks, there will be a gap, and that gap is called as the inter-block gap. The advantage is, if you write or read record by record, you are wasting storage space that is referred as the inter-record gap. That amount of storage space is wasted. For every record, you are wasting storage space. To minimize the storage space wastage and to maximize the usage, you go from inter-record gap to inter-block gap. That means, what is a block? A block is nothing but a group of records. As I mentioned before, a block can have 4 records or 8 records. It is generally powers of 2. Assuming a block is going to have 8 records, in that case, you write 8 records at one stroke or you read 8 records at one stretch. The advantage is, instead of wasting storage space for record wise, you are going to waste storage space only for block wise. That means all the 8 records are stored continuously. Thereby, you are minimizing the wastage of storage space and maximizing the utilization factor. This is about the magnetic tape. Then let us talk about the magnetic disk. I told you, disk is having the same access time. Whether you read the first record or the last record, you can directly go to the ith record and read the contents. Or you can read the first record, absolutely fine. Whether you are accessing the first record or the ith record or nth record, the access time remains the same in the case of a magnetic disk. And the disk is operated on a random access manner. That's why it is called as a random access device, whereas a tape is a sequential access device. Wastage of storage space is more in the case of tape, and wastage is less in the case of a magnetic disk. Tape is cheaper and disk is costlier. But kindly keep in mind, both are basically secondary storage devices or auxiliary memory devices. Auxiliary memory in short and sweet. And let us discuss about the disk. Of course, you have studied in your lower level classes. A disk is comprising of surfaces, top surface and the bottom surface. When you take up a magnetic disk like a floppy disk or CD-ROM, you would have come across in the past. There will be a CD-ROM drive. You will have, you can insert the CD-ROM into a CD-ROM drive. You can perform the reading operation. You can perform the reading operation from the contents which are already written into the device. Therefore, it has got 2 surfaces. And the top surface, let me call it surface 1, and bottom surface, let me call it as surface 2. And each and every surface is further divided into tracks. and tracks are divided into sectors. And for a disk, this is a single disk. If you are going to have a disk pack, your disk pack will consist of number of disks, and there will be a read-write head mounted, which will be taking care of your operations. To perform either reading operation or writing operation, there will be a read-write head associated or clubbed with your magnetic disk pack. And remember, whenever you say a disk is going to revolve, it is going to rotate. And remember, I told you in the beginning, a disk is divided into track, a disk surface is divided into track, and track is divided into what? Sector. What is a sector? A sector is a piece of storage or a segment of storage which can store a word length of your computer. What is a word length? You say 8-bit processor, 16-bit processor, 32-bit processor. When I say 8-bit processor is capable of handling 8 bits at a time. In other words, the word length or word size is equivalent to 8. In the case of a 16-bit processor, your CPU can handle 16 bits at a time. It is called as a 16-bit processor, and the word length is equal to 16 bits. Shortly, word length is referred as word. What does it indicate? It indicates the amount of processing capacity, or how many bits could be processed at a time by your processor or by CPU. That is called as the word length. In short, it is referred as the word. Let me come to the point of your disk. Quickly recall, your disk is having a surface, top surface and the bottom surface. You can call them as surface numbers. Surface number 1, top surface. Surface number 2 is bottom surface. The surface is further divided into tracks, and tracks are further divided into sectors. Probably I can show you the diagram bit later. I will show you the diagram. So that will give you a better picture about your organization of disk. So let me show you here. Yeah. Yeah, you can see here. So this is what I meant. So this is going to be a surface. Surface is divided into tracks. The concentric circles are called as tracks, and tracks are further divided into what? Sector. Remember, this is going to be the innermost track, and this is going to be the outermost track. You see, outermost track circumference is bigger, whereas the innermost track circumference is what? Smaller. But the number of bits stored will be one and the same. Therefore, this is a basic requirement when you go in for storing data onto your disk. So the sector size is larger. In other words, the number of space available for a sector at the outer circles are bigger in size, whereas when they come to the inner circles, which is closer to the center, they are very smaller in size. See here, this is going to be the size of a track, and this is also going to be a sector size. See here, this is size of one sector. This is bigger in size. This is size of one sector, which is smaller in size. If I'm going to draw one more circle inside, that particular sector size will be smaller. So remember, whenever you go in towards the center, it is going to be smaller in size. But keep in mind, each and every sector is going to store a word that is equivalent to the processing capacity of your computer. I can put this way for your understanding. This is going to be a concentric circle. Assume I'm going to draw one concentric circle. Assume I'm going to draw another circle. So this is going to be, this gap is referred as your sector. This is also a sector. The number of bits stored in both the sectors will be one and the same. Why? Because assuming it is going to be an 8-bit computer, the number of bits we are going to store in this sector is also 8 bits. In this sector also, it is going to be 8 bits. This sector has got more storage space, whereas this sector has got less storage space. But in spite of the available memory storage space within a sector, the number of bits stored remains the same. And this is a basic concept you have to keep in mind. The outer sectors, or the sectors available at the outer, away from your center, will be larger in size with respect to the sector space, but they store the same number of bits, which is stored in the innermost sector. Assume this is going to be track 0. This is going to be track 1. Let me draw. Let me draw one more here. So let me draw once again. That will be better. Okay, this is going to be another sector. See, the sector size or the space available is increasing, but the amount of bits stored in all the sectors will remain one and the same. And this is what I meant here as a read-write head. And the disk is going to revolve in this fashion. But the read-write head position is constant. Therefore, we normally call this as the access time is composed of two different factors, seek time and the latency time. So what is basically the seek time? Assume my data is stored in this particular sector. The head is positioned here. You have to wait for this particular sector to come under the position of the read-write head. Therefore, it has to revolve this way. The time taken for the particular sector to come under the position of this read-write head mechanism, this time is called as the seek time. And then time taken to perform the requisite operation, namely read operation or writing operation, it is called as your, let me say, latency time. So therefore, when you consider a disk surface, whenever you consider a disk surface, it is composed of sectors, and each sector stores one word, which could be processed by the computer. And the read-write head position is fixed, and it is going to revolve in this direction. And assuming that my required sector is, this is going to be, I have to read this particular sector, assume this way. Then it is going to be rotating in a clockwise direction. I have to wait for this sector. Let me say this particular sector in this outermost track is referred as n, and the innermost track is referred as n-1. Therefore, I want to read the particular track which is available in the nth track and this particular sector. Assume this is sector number I. I have to wait for this particular sector to come under the position of this head to perform the required operation, namely reading or word writing. This is called as your seek time. And then time taken to perform to get the data or store the data, that time is called as your, you can say, data transfer time or latency time. These are the two time factors composed of to make up the access time in the case of a magnetic disk. This is for one disk. Assume you are going to have a disk pack. You know, you would have seen a pack of, let me say, CDs. There will be a handle, spinning handle. In the spinning handle, you are storing number of CD-ROMs or number of, let me say, floppy disks. In olden days, we used to store, and that is what we call them as a disk pack. Similarly, this is going to be one surface, top surface, and the bottom surface. And the top surface, you can store, and the bottom surface also you can store. In other words, for each disk, there will be two surfaces. Therefore, you should know the surface number, disk number, surface number, disk number, whether it is disk 1. When you go for a disk pack, I'm going to have 6 disks. Each disk will be identified by a disk number. Within disk number, in which surface number the content is stored, in which surface, under which track it is stored, under which sector it is stored. Therefore, whenever you want to perform an operation in the case of a disk, these 4 informations are vital, namely disk number, then surface number, then track number, and then sector number. You know pretty well, each sector size is equivalent to the power of the processing power of your CPU, namely its word length. If your CPU can process 32 bits, then each and every sector can store 32 bits. If your CPU can process 64 bits, each and every sector can store 64 bits. This is equivalent to the word size of your computer. And keep in mind, it is going to rotate. And there is one more auxiliary storage device that is called magnetic drum. What is the difference between a drum and your magnetic disk? In the case of a disk, it is going to be a, let me say, a plate that is going to rotate, a flat plate that is going to rotate in a circular fashion. In the case of a drum, it is going to be a cylinder that is going to rotate in this fashion. You can see the arrow mark here. This is circular rotation, and this is your cylindrical rotation. That is a magnetic drum. What is the difference between a drum and a disk? Both can store the same amount of storage. In the case of a drum, it is slightly slower when compared with your disk. And the drum-based storage space when compared with the disk because of its more latency time. That's the reason why people prefer the use of disk when compared with the drum. That's the reason why, though magnetic drums are available in the olden days or in the past, but people prefer to use only magnetic disk. So this is about the auxiliary storage device. We can discuss about